In this class, we are going to learn how to complete an Anova table, and the experimental design that I'm going to be using is Randomized Complete Block Design. Okay, let's proceed to the question. In a maze trial involving three varieties of maize, we have V1 to V3, evaluated under 3 levels of nitrogen fertilizer. We have 0, 100, and 200 kg per hectare with 3 replicates. Complete the Anova table for the plant height of the maize generated from the experiment. Now, we have the table on the board. We are asked to complete this table with respect to the parameters that we are given in the question. Okay, now please, I want you to pay attention. Okay, you are going to understand. Just pay attention. Let's start by writing out the parameters that we are given in the question. Okay, we are given that in a maize trial involving 3 varieties. You understand? Now, how many varieties do we have? We are having 3. So that is the first parameters that we are given. We have variety is equals to 3. You understand? Okay. Evaluated under 3 levels of nitrogen fertilizer. So how many nitrogen fertilizers do we have? We are having 3 nitrogen fertilizers. So we have fertilizer as well. That is 3. That is 3. Okay. With 3 replicates. That means we are also having replicates. Replicates is also 3. Okay. Now, we are asked to complete the Anova table for the plant height of the maize generated from the experiment. See, all you have to do is that we have been given some values on this table. Is that not it? Now, in our previous class, I gave you some formula. You understand? There is a formula to calculate the degree of freedom, the sum of squared, the mean squared, the computed F, and though we've been given the tabulated F. Now, let us start by getting the total degree of freedom. Okay? Don't forget, in our previous class, I told you the degree of freedom is equals to n minus 1. You understand? Now, to get the total degree of freedom, see, what you see here, df simply means degree of freedom. You understand? Ss simply means sum of squared. Ms simply means mean squared. Computed F is the calculated critical value that we the calculated FK, you understand? Calculated value of our critical value. That's what we call computed F. And tabulated value is the critical value that we derive on the table. We've been given in the question. These are this. You can see at 5% and 1% respectively. You understand? So all you have to do is just to pay attention. Now, we need the total degree of freedom. To get total degree of freedom, the value of these cells, you understand? That is the total degree of freedom. To get total degree of freedom, you have to use this formula. Total degree of freedom is equals to the total numbers of sample that you have minus 1. Okay? The total numbers of sample that you have is the product of variety that you have, fertilizer that you have, and the replicate. Replicate simply means the numbers of times these samples repeat themselves. I mean, the numbers of times the variety repeat themselves. You understand? Look, you have how many variety? You have 3. How many fertilizer? You have 3. How many replicate? That is 3. To get the total numbers of sample, all you have to do is that just take the product of this, and this. Okay? So the total numbers of sample, which is Tn is equals to 3 multiplied by 3. That is what? 3 times 3 is what? 9. 9 times 3 is 27. So this will be 27. So to get the total degree of freedom, all you have to do is that 27, which is Tn, minus 1. That will give us what? 26. Okay? So the total degree of freedom is 26. So the value for these cells will be 26. Do you understand? Okay? Now, having gotten the total degree of freedom, let us get the replicate degree of freedom. The replicate degree of freedom, see, this is the formula for degree of freedom. Degree of freedom is equals to n minus 1. Whether replicate, whether variety, or total, degree of freedom is n minus 1. You understand? So, we've gotten the degree of freedom for total. Let's get the replicate degree of freedom. How many replicate do we have? See, replicate degree of freedom, please pay attention, is equals to the total numbers of replicate that we have, Rn minus 1. So replicate degree of freedom is total numbers of replicate that we have is 3. So we are going to have 3 minus 1, which is what? 2. Okay? So the value for these cells is 2. Okay? Now let's talk about the variety. The variety degree of freedom, VDF, is equals to numbers of variety that we have minus 1. How many variety do we have in this experimental design? We are having 3. So I'm going to have 3 minus 1 as well. 3 minus 1 is equals to 2. Okay, so the value of these cells is 2. Now we have fertilizer. How many fertilizer do we have? Fertilizer degree of freedom is equals to the numbers of fertilizer that we have minus 1. So the numbers of fertilizer that we have is what? We are given that it is 3 levels of fertilizer, which is 0, 100, and 200 kilogram per hectare. So we are going to have 3 minus 1, which is equals to 2. Okay, so the value of these cells is 2. Okay, now we have the interaction between the variety and fertilizer. How do we get the degree of freedom between the how do we get the degree of freedom between the of the interaction? You understand? This means interaction. Okay, the interaction between variety and fertilizer. Okay, so how do you get the degree of freedom? The degree of freedom is just the product of the degree of freedom of variety and fertilizer. Hello, please listen. Okay, it's simple. It's simple. Okay, all you have to do is that you have to take the product of the degree of freedom of variety, which is 2, and that of fertilizer, which is 2. You understand? So let me just give you the formula. The interaction, okay, I don't want you to get confused. Variety fertilizer degree of freedom is equals to variety degree of freedom multiplied by fertilizer degree of freedom. That is what? 2 multiplied by 2 equals to what? 4. Okay, so the interaction is the degree of freedom is what? Oh, I don't want to use red marker, so let's continue with blue. The interaction is what? Is 4. 2 times 2 is 4. Okay, now how do we get the error degree of freedom? To get the error degree of freedom, all you have to do is that you just have to subtract. Okay, let me just give you the formula. Okay, you see, if you want to understand, okay, you just have to pay attention to the explanation. Okay, when you understand, then you write. Do you understand? Now, how do we get the error degree of freedom? The degree of freedom for error. All you have to do is that error degree of freedom is equals to total degree of freedom minus the sum of the replicate degree of freedom, the variety degree of freedom, the fertilizer degree of freedom, and the variety fertilizer degree of freedom. You understand? That is the formula that we are going to use to compute the error degree of freedom. Do you understand what I'm saying? Listen. That means that error degree of freedom is equals to error degree of freedom will be equals to total degree of freedom is 26. So I'm going to have 26 minus replicate degree of freedom is 22. So I'm going to have minus 2. Oh, it's 2. Sorry, it's not 22. Okay, it's 2. So 2 plus variety degree of freedom is 2. You understand? So here I'm going to have 2. Fertilizer degree of freedom is 2 as well. So I'm going to have plus 2 plus variety fertilizer degree of freedom is 4. So I'm going to have plus 4. Okay. So the error degree of freedom is equals to 26 minus 2 plus 2, 4. 4 plus 2, 6. 6 plus 4, 10. 26 minus 10 is what? That is 16. You understand? So the error degree of freedom, that is the degree of freedom for error, is 16. Do you understand? Okay, so that is, we are done with the degree of freedom. That is the that's how to get the degree of freedom. So if you come across this question, you first smash the degree of freedom side, then you proceed to the sum of squared. Now, how do we get the sum of squared? It's simple. Okay, you see, if you are part of our previous class, I'm very sure you'll be able to solve this because I did a class specifically on it. The class is about 1 plus 1 hour plus. You understand? So maybe if you missed the class, just check the description of this video, or you can check the playlist on this channel. Okay, so now how do we get the sum of squared? You see, I'm very sure you are done with this, so I'm going to erase this. Okay, since we are done with the degree of freedom, I think there is no need to keep this as well. Now let us get the sum of squared. The sum of squared is given by this formula. Sum of squared is equals to mean squared. Oh, sorry. You see, please, I want you to pay attention. I want to make it simpler as much as possible so that you won't need to cram before you remember the formula, okay? You don't need to cram like. Now, see, there is a relationship that exists between mean square, the sum of squared, and the degree of freedom. In our previous class, I gave you a formula that mean squared is equals to sum of squared all over degree of freedom. You see, you don't need to cram, okay? You don't need to cram. All you have to do is just to pay attention. And that is why I want to make it simpler so that you don't need to cram. Now, mean square is equals to sum of squared all over degree of freedom. Now, we want to get the mean square for this. That means that I'm going to divide the mean square for total will be total sum of squared minus degree of freedom for total. You understand? Oh, all over the degree of freedom for total. See, since mean square is equals to sum of squared all over degree of freedom, that means that total mean squared is equals to total sum of squared all over the total degree of freedom. Or, and in some cases, you might put it as SST, sum of squared total. You understand? So it's still the same, okay? All you have to do is that just know the parameter that you are saying. Now, total mean squared is equals to total sum of squared all over the total degree of freedom. The total sum of squared is what? 6,978. So I'm going to have 6,978 all over total degree of freedom is 26. So all over 26. That means I'm going to have 6,978 divided by 26. That will give us 268.38. 268.38. So here I'm going to have 268.38. That is the total mean squared. Okay, let me use blue pen, okay? 268.38. Okay, now let us get the replicate mean squared, okay? We've gotten the total mean squared. Let us get the replicate mean squared. The replicate mean squared is equals to the replicate sum of squared all over the replicate degree of freedom. Replicate mean squared is equals to replicate sum of squared is what? 156.22. You understand? So I'm going to have 156.22 all over the replicate degree of freedom. The replicate degree of freedom is what? Is 2. So I'm going to have all over 2. So replicate mean squared is equals to 156.22 divided by 2. That is 78.11. So here I'm going to have 78.11. Okay. So the replicate mean squared is 78.11. Now let's come back to sum of squared. We've been given the mean square of variety. You understand? We've been given the variety mean squared. Now we are asked to determine the sum of squared, the variety sum of squared. You see, I told you the relationship that exists between mean squared, sum of squared, and degree of freedom is what? Is mean squared is equals to sum of squared all over degree of freedom. You understand? So now, since we've been given the sum of squared, we've been given the mean squared of variety. So we can easily say that mean square of variety. Oh, I don't want to use blue pen. Okay, let's use black. Let's proceed with black. The mean squared for variety, that is variety mean squared. Sorry, variety mean squared is equals to variety sum of squared all over variety degree of freedom. Now, variety mean squared is what? 928.11. Sorry, 928.11 is equals to variety sum of squared. It is unknown. We don't know the variety sum of squared. So we're going to put it as variety sum of squared all over. Let me get so that it will be clear. Let me use this variety mean squared. Okay. So 928.11. 928.11. Okay. I'm very sure you can see it clearly now. Can you see it clearly? Yeah. Okay. So we don't know the variety sum of squared. So that is the parameter that we want to calculate. And we know the variety degree of freedom as 2. So we're going to have this all over 2. Okay. Now the next step is that you just have to take the cross product. So variety sum of squared is equals to variety mean squared, which is 928.11 multiplied by 2. Okay. So variety sum of squared is equals to 928.11 multiplied by 2. That is 1856.22. 1856.22. 1856.22. Okay, so you can see now. So now you can determine the fertilizer sum of squared. Can you can try this. Okay, try determining the fertilizer sum of squared. Okay, I want to test you. Check, try to determine the value of these cells, which is the fertilizer sum of squared. Let me erase this. When you are done, you can play the video to check maybe you are correct. Okay. Now, to determine the fertilizer sum of squared, don't forget that the mean squared is what? Sum of squared all over degree of freedom. So fertilizer mean squared FMS is equals to fertilizer sum of squared all over degree of freedom for fertilizer as well. So fertilizer mean square has been given, which is 2169.00. So 2169 is equals to fertilizer sum of squared, which you don't know. We don't know the value, do you understand? All over the fertilizer degree of freedom, which is 2. The fertilizer degree of freedom is 2. So I'm going to have here the cross multiply fertilizer sum of squared is equals to multiply by 2. So the fertilizer sum of squared is equals to 2169 multiplied by 2. That is 4338.00. So 4338.00. Okay. Now, okay, let's determine the value of these cells, which is the variety fertilizer mean squared. All you have to do is that, since you know that mean squared is what? Sum of squared all over degree of freedom. So that means that variety fertilizer mean squared is equals to, okay, let me write this, 441.7. Oh, sorry. That is 4338.00. 4338.00. You understand? Okay, now let's determine the variety fertilizer mean squared. The variety fertilizer mean squared is equals to variety fertilizer sum of squared all over variety fertilizer degree of freedom. Okay, so variety fertilizer mean squared is equals to variety fertilizer sum of squared is what we've been given. That is 441.78. 441.78 all over variety fertilizer degree of freedom. That is 4. So 441.78 divided by 4. That is 110.445. You understand? 110.445. Okay? 110.445. That is the variety fertilizer mean squared. Okay? Now, let us determine the mean square of error sum of squared. Error sum of squared, because we cannot get the error mean squared without getting the error sum of squared. You understand? Okay. So how do we determine the error sum of squared? See, it's simple. Okay, you just have to pay attention. Error sum of squared with the, let me give you the formula. Are you done with this? Okay. So since you know that sum of squared, mean square is what? Sum of square over degree of freedom. So we cannot determine the value of the error mean square without knowing the sum of squared. So we have to determine the error sum of squared. See, error sum of squared is equals to the total sum of squared minus replicate sum of squared plus variety sum of squared plus fertilizer sum of squared plus variety fertilizer sum of squared. You understand? The error sum of squared is the difference between the total sum of squared and the sum of replicate sum of squared variety sum of squared, fertilizer sum of squared, and the variety fertilizer sum of squared. So let's proceed. Here I'm going to have the error sum of squared will be equals to, see, total sum of squared is 6,978.00. So 6978 minus, okay, 156.22, 156.22 plus 1,856.22 plus 4,338 plus 441.78. 441.78. Please, can you see what I wrote? Can you see what I wrote here? I wrote 441. Okay, let me write it very well. 441.78. You understand? So here we are going to have the error sum of squared is equals to 6,978 minus. Okay, now let us sum all this together. 156.22 plus 1,856.22 plus 4,338 plus 441.78. That is 6,792. 6,792.22. You understand? We have minus 6 and 7. Okay, yeah. Okay, so we are going to have error sum of squared is equals to 185.78. You understand? So the value for these cells is 185.78. Do you understand? Okay, so now let's get the value for these cells. To get the value for these cells, that is error mean squared. You understand? Error mean squared is error sum of squared. Error mean squared is equals to error sum of squared. Please pay attention, okay? Error mean squared is equals to error sum of squared all over the error degree of freedom. You understand? So error sum of squared is what? 185.78 all over error degree of freedom, which is 16. Okay? So the error mean squared is equals to 185.78 divided by 16. That will give us 11.61. 11.61. Okay? So the value for these cells is 11.61. Okay? So do you understand how I'm getting the value? Now, we are done with degree of freedom. We are done with sum of squared. We are done with mean squared. Now, it remains computed value. I mean, calculated value. You understand? F cap. Computed F. Computed critical value. Okay? Now, how do we determine the computed critical value? It's simple. Now, look at what we have here. All we need here is the computed value of variety fertilizer and variety fertilizer. You understand? So I'm going to give you the formula, okay? I'm going to give you the formula. The formula for computed value, FK, you understand, is, please pay attention. The formula for FK for computed value is FK for the parameters that you want to calculate all over the FK of mean. You understand? I'm going to explain, okay? To get the computed value, FK is equals to mean square all over error mean square. Let me just put it like that, okay? Please pay attention. It's simple, okay? That's why I take time to explain. You see, you know that we need the F calculated for 3 parameters. We need the F calculated for variety, we need the F calculated for fertilizer, and we need the F calculated for variety fertilizer. Now, to get the F calculated for variety, I'm very sure you are done with this, right? So let me erase this. Now, to get the F calculated for variety, F calculated for variety will be equals to, now, don't forget that FK is equals to mean squared all over error mean squared. So, F calculated for variety is variety mean squared all over error mean squared. So, variety mean squared is what? Variety mean squared is 928.11 error mean squared is what? 11.61. So I'm going to have 11.61. So 928.11 divided by 11.61. That will be 79.94. You understand? So this will give me 79.94. So the value for these cells is 79.94. Now, even we don't need the fertilizer, the fertilizer FK, because we are not given the critical value. You understand? We are not given the critical value for the fertilizer, for fertilizer. So, but you can still determine it. You understand? You can find it. Then you just have to make use of fertilizer mean squared. You understand? FK for fertilizer is equals to fertilizer mean squared all over error mean squared. You understand? So fertilizer mean squared is what? 2169. 2169 all over error mean squared. The error mean squared is what? 11.61. So I'm going to have 11.61. So here 2169 divided by 11.61. 2169 divided by 11.61. That is 186.82. Okay, 186.82. So the value for fertilizer FK is, FK simply means computed value. You understand? Computed value of critical value. Are you paying attention? Calculated value. That's it. So FK for fertilizer is 186.82. Now let's calculate the variety fertilizer FK, because that's important to us. And the reason is because we are given the critical value at 5% and 1% respectively. Okay, so I'm very sure you are done with this. Are you done? Let me just do it here. Variety fertilizer FK is equals to variety fertilizer mean squared all over variety, all over error mean squared. You understand? All over error mean squared. Okay, let me erase this. So variety fertilizer FK is equals to variety fertilizer mean squared is 110.445 all over variety fertilizer all over error mean squared. That is 11.61. Okay, so variety fertilizer FK is equals to 110.445 divided by 11.61. That will give us 9.51. You understand? So here will be 9.51. Okay, so the value for these cells will be 9.51. You understand? So 9.51. Now you can see that we are done with the computed value. We have completed the Anova table. So you can just put dash here, put dash here. You understand? So we are done with the question. This is the Anova table that they want us to complete. We are done with the question. Now before you go, I want you to like and share this video. You understand? To your classmates, to people that you know that they need video like this. You have to share it. Share the video to them. You understand? Okay. And also, if you download this video, maybe you download this video and you are watching it offline, please, when you are done, come back to YouTube, subscribe to the channel, and like and comment what you learned in the video. Okay, so that is all for this class. See you in the next class.